Have you ever stared at a cryptic error message, feeling completely lost, wondering what your code was trying to tell you? It can be a truly frustrating experience, making you feel stuck and unproductive. When you ask an artificial intelligence tool to analyze an error, it embarks on a sophisticated multi-step process to understand, diagnose, and ultimately help you resolve the issue. Think of it as having a highly advanced, tireless detective examining your code. First, the artificial intelligence begins by diligently collecting all available information. This includes your specific code snippet, the full error message that appeared, and any associated stack trace which details the sequence of function calls leading up to the error. This comprehensive data gathering is crucial for a thorough analysis. Next, it moves to pattern recognition and semantic understanding. The artificial intelligence uses a process called tokenization, breaking down both the code and the error message into individual, meaningful components such as keywords, operators, and variable names. These tokens are then converted into numerical representations known as embeddings. These embeddings allow the artificial intelligence to understand the context and relationships between different parts of the code and the error message. It compares these numerical patterns against its vast training data, which includes millions of documented errors and their corresponding solutions. This enables it to identify similarities, even if the exact wording of your error is unique. Beyond just recognizing patterns, the artificial intelligence strives for semantic understanding. It aims to comprehend the meaning and intent behind your code, not just its syntax. This deeper understanding helps it to grasp what your program was supposed to do, and how the error deviates from that expected behavior. This step is vital for moving beyond superficial suggestions to actual root cause identification. Following this, the artificial intelligence performs a root cause analysis. Like a skilled detective tracing clues, it works backward from the error message to pinpoint the underlying reason for the problem. This might involve examining the state of variables, the flow of execution through different functions, or subtle logical flaws within your algorithm. It determines why the error occurred, not just what it is, which is key for a lasting fix. Finally, based on this deep analysis, the artificial intelligence generates potential solutions. These solutions can range from suggesting specific code modifications to proposing alternative approaches or debugging strategies. It draws upon its extensive knowledge base of best practices and common fixes, presenting its findings and recommendations in a clear, understandable format. It will also often provide a concise explanation for why it believes its suggested solution is valid, empowering you to learn and grow. For you, this powerful process often starts by simply pasting your error message and perhaps some surrounding code into your preferred artificial intelligence coding assistant. You can then ask it specific questions like explain this error, or suggest a fix, or even what are common reasons for this kind of error. The artificial intelligence will then leverage all these steps to give you a helpful response. The remarkable capability behind this process is largely thanks to what are known as large language models, or LLMs. These advanced models are trained on immense datasets of code, documentation, and human language. This training allows them to not only process text but also to understand programming logic and common pitfalls. The creation of those numerical embeddings enables the artificial intelligence to find incredibly subtle connections between new, unfamiliar errors and existing solutions within its training data, even if the phrasing is different. Ultimately, artificial intelligence transforms the often intimidating experience of encountering error messages into an empowering learning opportunity. It helps you quickly understand complex issues, learn from your mistakes by explaining the why behind solutions, and significantly reduces the time you spend debugging. This allows you to focus more on creating and innovating, making you a more efficient, confident, and skilled developer.
If this helps you code smarter, like, subscribe, and build with us.